Hello students, welcome to this lesson. You came across trigonometry at GCSE. Let's start this session by recapping some of the important things you may have already remembered. Trigonometry is all about triangles. At very high level, we can split the triangles into two. Right angle triangles, any other triangle. Right angle triangles. As we know, let me draw a right angle triangle for you. As we know, right angle triangle is a special type of triangle. This angle is 90 degrees. Let's denote this angle as theta. We call this side, the side opposite to this angle, as opposite. This side is called adjacent. Most importantly, the side opposite to right angle is called hypotenuse. If you go back to other triangles, there are a number of triangles. Isosceles triangles has two equal sides. These two sides are equal, therefore these two angles are equal. Equilateral triangles, all three sides are equal, therefore each angle is 60 degrees. Scale and triangle could be any triangle, arbitrary, right? It's not necessary that any of the side must be equal to any other one. Acute triangle, where all the sides must be less than, all the angles must be less than 90 degrees, right? All of them are acute angle, less than 90 degrees. Last one is obtuse angle, where one angle is bigger than 90 degrees. Let's focus on right angle triangle. Let's denote this angle as theta. This is the right angle. You may recall Pythagoras theorem and trigonometric ratios from GCSE. So what is Pythagoras theorem says? That the square on the hypotenuse is equal in area to the sum of the square on the other sides. Okay. For an example, let me draw a simple right angle triangle. I draw a square along this axis and on this axis. Area of this one is 25. 5 squared is 25. Area of this one is 16 centimeter square. Area of this one is 9 centimeter square. So as according to Pythagoras theorem, 9 plus 16 is equal to 25. To generalize this formula for Pythagoras theorem is that hypotenuse square. So let's denote hypotenuse as h. So h square is equal to adjacent square plus opposite square. I'm sure you may remember this one. Now, trigonometric ratios. The trigonometric ratios are the next important concept associated with the right angle triangle. There are 6 trigonometric ratios, but let's go through the first 3. These 3 trigonometric ratios are sine, theta, cos and tan. These are abbreviated to the ratios. These are referred to as ratios since they can be expressed in terms of the sides of a right angle triangle for a specific angle theta. If you still refer this image, sine theta right? So the ratio between the opposite sides and hypotenuse is called sine. So sine theta is equal to opposite divided by hypotenuse. Similarly, the ratio between the adjacent and hypotenuse is called cos theta. So A over H. Ratio between opposite over adjacent is called tan. So opposite over adjacent, right? So you can find this formula in your formula sheet. However, you may remember using this mnemonic called SOH-CAH-TOA. SOH-CAH-TOA. So from so mean sine equal opposite over hypotenuse. If you remember the equation triangle, if you put sine is equal to opposite divided by hypotenuse. So this equation triangle is useful. CAH. From CAH, cos equal to adjacent over hypotenuse. From TOA, tan equal opposite over adjacent. Right. So the question now is there any formulas or concept that we should remember for other triangles? Yes, there are. There are two formulas, sine rule and cosine rule. To explain these rules, let me denote the sides of this triangle with small a, b, c. Let's say this side is length is equal to a, this side length is equal to b, and this side length is equal to c. The angles opposite to these sides. So for example, this angle is opposite to small a. So let's denote this angle as a, this angle as b, and this angle as c. Right? So the sine, what sine rule says, the ratio between side A over sine A equal to the ratio between side B over sine B, and this is equal to the ratio between sine C over sine C. You can also write this formula like sine A over small a is equal to sine B over small b is equal to sine C over C. Now cosine rule. So the cosine rule says that if we choose this a as a reference, then it's a square, square of side A is equal to b square plus c square minus 2bc cos A. Okay. Similarly, if you use cos B as a reference, then b squared equal a squared plus c squared minus 2ac cos B. Again, if you use angle C as a reference, c squared equal a squared plus b squared minus 2ab cos C. We take this equation, and if we make cos A subject, we can actually make cos A subject, say cos A equal to b squared plus c squared minus a squared divided by 2bc. So this equation would be useful if you want to find angle A given that all three sides are known, or this equation would be useful if we want to find the one side given that we know two sides and angle. Okay, now look at the another equation that would be very useful in triangles, that is how to calculate the area of a triangle, right? So area of the triangle, area of this triangle is given by, let's say, area is half times AB sine C, right? If you know these two sides and if you know the angle of this one, then area would be half AB sine C. Or we can calculate the area by half AC sine B or half BC sine A, right? So if you want to calculate the area, what is important is we need to know two sides and the angle between the sides. We will do a couple of questions on all of these formulas. So please move on to the next video.